About a month ago, I bought a Ryzen AI Max 395 Plus, mostly because it's an affordable option to get a lot of VRAM. Now, AMD, of course, markets their product as having impressive performance. We're going to test that. So if you're in the market to buy one of these things, or if you're just curious as to what a machine with 112 gigabytes of VRAM looks like, then this video's for you. Just a quick disclaimer, I'm not sponsored by anybody. I don't have any special access or anything like that. I'm just an enthusiast who likes to run local AI models. So let's start with the computer itself. I specifically bought a framework desktop. It touts 128 gigabytes of memory. I'll explain more about the shared memory architecture later. And it comes in a nice compact form factor. You can see here that I have it sitting on top of a Blu-ray player, and on top of it is a Raspberry Pi. Next to it is my server, which is a mini ATX form factor. It's already pretty compact by desktop standards, but the framework is just so much more space efficient. It's crazy. The whole thing cost me roughly $2,800. That's including the 7 terabytes of solid-state storage. I still have one slot left for a future upgrade. I bought one of these PCIe to NVMe adapters. The framework has one spare PCIe slot that I can use when I need to expand my memory. I installed Arch Linux on it. I think it's a good choice because usually Arch is pretty good about up-to-date packages. And that's pretty important, especially at this stage, because this is a brand new processor. I got this at the end of November, and I was watching in real time as firmware updates were coming out for stability. In fact, when I got this thing, I had to install an experimental AMD microcode update that came out that same day in order for me to be able to boot. And that's partly why it's taken me so long to be able to review this thing in the first place. When I first got it, ComfyUI only partially worked. I got it stable enough for me to do some benchmarks, but support is still experimental. And I find it kind of interesting that people were reviewing this thing back in August. There's no way any of this stuff worked, which is probably why the reviews were mostly about gaming and some generic benchmarks and running some large language models. I think LM Studio had pretty early support for this chip, but for PyTorch applications, ROCm 7.1 still has nightly releases. It's very experimental. So be aware, be warned, this chip is new. And if you're not an early adopter and you don't like troubleshooting, I would say hold off on this one for a bit. Of course, if you're watching this 6 months from now, the stability issues have probably been solved by now, but just be aware that out-of-the-box compatibility is a bit exaggerated. Now let's take a look at some benchmarks. By the way, I have this write-up on GitHub. I'll link to it in the description, but I'll go over it with you and do some real-time demonstrations. So first, I did Whisper Timestamped. It transcribes audio. It doesn't take a lot of VRAM, but it is very computationally intensive. So the relative performance here will allow us to get our bearings for subsequent tests. I have my benchmarks here for 4 different AMD GPUs. The Ryzen AI Max is shown here as the 8060S, and I have a 6950 XT, a 6800 XT, and a 6750 XT. All of these are desktop GPUs with the exception of the AI Max, which is technically a laptop processor. And it's not exactly the fastest kid on the block. Even the mid-range 6750 is twice as fast. I will caveat here that the performance is not set in stone for the 8060S. To show you what I mean, here's a plot showing different runs and different installations of PyTorch on different days. So I would like to emphasize that these benchmarks are the product of the time they were recorded using unstable versions of PyTorch. But here's another example with similar results to Whisper. These are the tokens per second of a 7 billion parameter large language model. But the results here shouldn't be that surprising, right? We've got desktop GPUs that use roughly twice as much power as the AI Max. Really more than twice as much power because these are the power numbers for just the GPU, and the AI Max is a CPU and GPU combined. And we can see that the 6800 XT runs circles around the AI Max. But here's the thing. The strength of this iGPU is not in it being a powerhouse, it's that it's got a lot of VRAM. Now, here's where I have to make a diversion and talk about the shared memory architecture. The chip has 128 gigabytes of unified memory. If you're used to a desktop setup, you've got a separate GPU plugged in on PCIe with its own dedicated memory, but this is all one chip and it all accesses the same memory. I don't know how this manifests on Windows, but on Linux, this memory is truly shared. There's not a distinction between RAM and VRAM. You just have a pool of memory to draw from. Now, you do configure how much of that memory is allocatable by the GPU, and I tried setting it to 120 gigabytes, but it seemed to make the system a bit unstable, so I backed it off and stuck with 112. But keep in mind, that's not really a hard limit. It's just a configuration that you set in the boot parameters. Now, this makes estimating VRAM usage a little bit difficult because the tools that we have available, like Radeon Top and BTOP, don't really display VRAM usage like it would on a desktop. You can kind of deduce how much VRAM is being used by looking at the amount of memory your processes use and subtracting that from the total allocated memory. But even that is a little bit fuzzy because there could still be page files allocated that aren't used. But there are serious advantages to using this shared memory architecture. For instance, Qwen Image Edit, which is a very heavy process, uses a lot of RAM, over 32 gigabytes sometimes. And I know of an LLM that I can run that uses over 100 gigabytes of VRAM, but next to no RAM. So on a traditional desktop layout where the memory is separate, you just wouldn't be able to run these extreme examples. So let's go back to our 7 billion parameter model. It uses roughly 9 gigabytes of VRAM, and that's obviously good enough for the 6800 XT with 16 gigabytes. But what happens if we bump it up to a 24 billion parameter model that uses 30 plus gigabytes? Now the system with the 6800 XT is going to offload half of that memory to CPU. And here we start to see the true nature of the VRAM bottleneck. Now the AI Max is running circles around the 6800 XT.
Well. How the turntables.
And if these arbitrary numbers on a graph don't mean much to you, here's a 24 billion parameter model running in real time on the AI Max. It outputs tokens faster than I can read, which is good enough for my purposes, and this is roughly 3 times faster than on a 6800 XT. But here again, we run up against the limitations of this laptop-grade GPU. When I bump this up to a 70 billion parameter model, I have the VRAM for it, but I don't have the juice. And for the record, this is roughly 3 tokens per second, which is about the same speed as the 24 billion parameter model running on the 6800 XT. Now, in relative terms, this model runs 4 times faster on the AI Max than the 6800 XT, but in practical terms, it's too sluggish to be useful. Now, here I'm going to have to make another digression and talk about quantization. Now, normally when people talk about GGUF quantizations, they're talking about VRAM usage, but in this context, where VRAM is not a bottleneck, quantization type still matters, and it affects inference time. Here I have a plot of the same model running on various different quantization sizes. Now, remember, I have enough VRAM for all of it, so that's not really what's making the difference here, but something else is going on. Is it the total file size? Smaller quantizations use less total memory, and that might be a factor, but let me show you this. This is GLM 4.6. It is 357 billion parameters, and I am running a 2-bit quantization. The file size is 97 gigabytes. It is by far larger than any of the 70B quantizations. And you can see that the performance is all over the place depending on context length. For 0 context length, it's actually the fastest. And for most context lengths, it's generally on par with the same quantization type for the 70B. But wait, there's more. GPT OSS 120B. This model is just built different. It uses a new format called MXFP4, and it outputs tokens at a blazingly fast 40 tokens per second. That is blink and it will fill up the page type speeds. And this model is pretty big. It's 63 gigabytes. And it's a perfect demonstration of the vast difference when you have a VRAM bottleneck. There's a much smaller and much faster version of this, the 20B version, that I'm running on the 6800 XT, and the 120B I'm running on the AI Max. The only advantage in this situation that the AI Max has is VRAM, and it clearly matters because it runs the larger model faster than the 6800 XT. For reference, here are all the models that I benchmarked on the AI Max. You can see that the OSS 120B is just a different beast altogether. All right, enough LLM talk. Let's do image and video generation. After all, what's the point of buying this if you're not going to run comfy UI? And let's start with the classics. Let's try Stable Diffusion XL. Now, I know what you're thinking. Stable Diffusion XL, that could run on as little as 6 gigabytes of VRAM. Who cares? But if you're used to using a mid-range GPU, you might not realize how much CPU offloading is actually going on. So let's see how the AI Max stacks up. Here I made a pretty simple workflow that I used for the benchmark. First, it tests generating a 1024 by 1024 image, and then it upscales it and processes it at 2048 by 2048. Now, this isn't representative of what I actually do when I use SCSL, but it is representative of generation time for benchmarking purposes. And here are the results. Surprisingly, it's a tie at base resolution between the 6800 and the AI Max. Now, I didn't actually expect to see this. I expected the 6800 to outperform it. And then when we look at higher resolution images where much more CPU offloading is required, the AI Max just smashes it. The VRAM bottleneck strikes again. All right, that's all well and good, but what about Z image? After all, this thing was engineered to work on 16 gigabyte card. There's no way that the AI Max can win against the 6800 XT in this situation. So let's run the template default workflow for Z-Image Turbo. I ran it 6 times and took an average. The results were generally consistent. I verified that the 6800 XT was working at full speed. There was no CPU offloading during main inference. However, during that crucial last step, VAE decoding, where the image is rendered into pixels, it started to offload to CPU. And this caused it to lose time, enough to be significant. The AI Max is just faster by 10 seconds consistently. Now, I wasn't expecting these results either, but I guess the lesson is don't underestimate the VRAM bottleneck. All right, now let's talk about something that's a little bit harder to compare apples to apples, and that's WAN image to video. Of course, you can run WAN 2.2 on as little as 12 gigabytes of VRAM using a GGUF quantization and by selecting your image size carefully. So first off, let's get our bearings here and try out the Q4K quantization so that we can compare the 6800 and the AI Max directly. As you can see, for lower resolutions, it's actually a tie, but as resolution increases, time increases more exponentially for the AI Max than the 6800 XT. So on the upper end, the 6800 XT just smashes the competition. But that's not the end of the story. A Q4K quantization is a size-quality trade-off. And what if we don't want to make a trade-off? What if we want to use the full weights? Well, that's just not possible on the 6800 XT. It uses so much memory that I don't even have enough in the system, even if I do CPU offload. And even if I could fit it in RAM, it would take forever. But I can run it on the AI Max. So let's see the results. On the upper end of resolution, this thing takes an hour, which is a really long time to wait for 5 seconds of video. And by the way, I'm not even bumping up against the memory limit here. I ran this at 1440 pixels, and it ran it. It took 10 hours, but it did run. But this is just a nice handy reference to have for all these various resolutions, especially if you're going to be feeding this into upscaling and interpolating, which can take a long time depending on the method used. So I'll be using this chart to find the right sweet spot when messing with all that stuff. But now you're probably tired of looking at benchmarks, but let me show you one last practical application. I use Qwen Image Edit on a regular basis. It's useful for doing simple basic edits, and it's actually pretty good at removing things like text and semi-transparent elements. I typically use it through the Krita plugin, which makes everything pretty easy and streamlined. Being an image-to-image model, the amount of VRAM it uses is going to depend on the resolution, and the model itself is quite heavy to begin with. I settled on using a Q6K quantization, which is over 16 gigabytes by itself. There are smaller quantizations, but I kind of wasn't vibing with the Q4K version because I just personally felt that the quality loss was too much. But I've regularly been using it for a couple months now. The problem is that it's slow. Processing a 1280 by 720 image takes 3 minutes. It's not horrible, but it's enough to make you pause and think for a second before hitting the generate button. But now that I have the AI Max, I can use the full FP16 weights. So I moved from something about 16 gigabytes in size to about 42 gigabytes in size. And it can process the same image in about 1 minute. And if that wasn't fast enough, I can switch to the FP8 weights and run everything in about 45 seconds. So here's an example of a real-world situation where I'm able to switch to something of higher quality that takes less time. All right, I'm done with benchmarks, I promise. So let's get to the bottom line. I bought this thing for about $2,800, and probably $600 of that was hard drive space. I think if you're coming from maybe a mid-range gaming PC like me, and you want to try those large AI models and you just don't have the VRAM to do it, this is probably one of the most affordable ways right now to get over 100 gigabytes of VRAM. Just tamper your expectations a little bit, because even if it has the memory to run really big models, it might be kind of too slow to be practical. But for other things like images and video and music, you basically never have to worry about running out of memory. In fact, I've never really thought about it when running any of these models. I just think about inference time, and quite frankly, it's better than the 6800 XT almost all the time, except for some corner cases like transcription where the model uses only a few gigabytes of VRAM. But I'd say, by and large, the biggest factor to generation time is the VRAM bottleneck. I can't speak to how well it plays games or really anything besides running local AI models, because that's what I bought it for. But I'd say what you get for the price is a really good deal. Now, I did buy this a couple weeks before the RAM apocalypse, so the price is gonna go up. And honestly, I think getting any configuration less than 128 gigabytes is not gonna be all that useful. And there's not really a path to upgrading your memory later. The memory is soldered on, so just keep that in mind. But yeah, overall, I'm really happy with my purchase, and I'm going to be able to mess with AI stuff that I simply wasn't able to do before. So maybe if you are looking for a server, or if you currently have like a really crappy laptop and you've just been holding out for that one thing that'll be able to run AI, this is perfect. It's not like in the same category as like 4 3090s or like an A100, but for what it is, it's good. By the way, I didn't even talk about the CPU. It's like amazing. It's better than a lot of desktop CPUs. So for like traditional CPU intensive compute tasks, this is great. But I've been rambling long enough. This video's approaching the 20-minute mark, and I don't really have anything else to say anyway. So I hope you found this interesting. I hope you learned something. Thank you for watching, and have a nice day.